All right, AP Statistics, we are going to talk more about the normal curve in this video. Obviously, this is all the chicken scratch that I've written from my other video, but I just wanted to remind you that we've talked about the normal curve in general, and we've talked about the empirical rule, and we've discussed that in quite a bit of detail. And now that brings us to, in our notes, standardizing a normal score. So I'm going to give you some detail about what this means and how to find it and why we even need it. So the first thing, how do I standardize a normal score? And what is the name of the standardized value? And what does the standardized score represent? So you can get all of this information in the PowerPoint, but I need to help you understand why we really need to use it. So the first thing is I want to go back to the empirical rule and look at this idea that if I have my mean and my standard deviation, then I can calculate this value at 1 standard deviation, 2 or 3 above the mean, and then these are 1, 2, and 3 standard deviations below the mean. The empirical rule works great for those 7 values. Anything outside of that, maybe something falls right here, okay, just to the left of the mean, but not quite 1 standard deviation. Well, where is it? I need to know that. So the z-score basically tells me how many standard deviations away from the mean a particular value is. So when I talk about what a z-score is, because a z-score is our name for our standardized value, our z-score tells us how many standard deviations away, oh, sad face. Sorry, I accidentally erased that. How many standard deviations away from the mean a particular, if I can spell that, value would be. For instance, let's revisit the idea of using the normal model for IQ that we used in one of our examples, okay? So I know that this model has a mean of 100 with a standard deviation of 16, so if I draw my graph, okay, so it looks something like that, only probably prettier in real life, but whatever. All right, so let's say I want to know something about an IQ of 90. Well, the IQ of 90 does not fall at 1 standard deviation below the mean. It's 10 points below the mean, and 16 points is a whole standard deviation. So if I want to know how many standard deviations from the mean that would be, obviously it's going to be less than 1, because 1 would be at 84. So I can use the following equation to find how many standard deviations from the mean that 90 would be. So this equation right here is what will allow me to find any z-score. If you'll notice though, you have to know the mean, the standard deviation, and of course the x. What is the x, Miss Griggs? Well, it's that 90 right there. It's the value I'm interested in. So when I find my z-score, I'm going to have 90 minus 100 over 16, because 100 is the mean and 16 is the standard deviation. And then when I find this, I get a negative 10 over 16, which the decimal for that would be negative 0.625. All right, 2 things you need to notice here. It's okay to get a negative, and it makes sense because 90 is below the mean. All of your z-scores below or to the left of the mean are negative. And all of the z-scores to the right of the mean or above the mean are positive. So this actually helps you determine, okay, am I looking in the right place? It kind of helps you get your bearings. So the IQ of 90 is negative 0.625 standard deviations. So in other words, it is 0.625 standard deviations below the mean. That tells you in relation to other values where it falls on the entire distribution. So that's what a z-score is. Z-scores are just standard deviations. How many standard deviations from the mean will I be? So let's look at this in more, in a deeper concept type observation, I guess is the word I want to use. Okay, why do we do this? Well, we do it if we want to compare values for different units. For instance, let's say you and your friend take a standardized test. You take the SAT, your friend takes the ACT. I've actually got an example like this that I'm going to do a video over. So when you each get your results back and you compare them, since they're graded on different scales, you can't really tell who did better. But if you standardize them and find their z-scores based on their own distributions, whichever one is farther above the mean, that's the person who did better. So standardizing allows us to compare different units of measure to see how they fall in relation to their own mean value. So that's kind of what we use these for as well. They're quite convenient for things like that. So when we use this method, I want you to notice this right here because this is kind of difficult to understand. We standardize any normal distribution so that we can use the areas from a standard normal distribution where the mean is 0 and the standard deviation is 1. What does this mean, Miss Griggs? Well, here's the deal. If you will think about this, when I refer to a standard normal distribution has a mean of 0 and a standard deviation of 1. Well, why do we call it that? Well, we call it the standard normal distribution because it's standard. We're starting from nothing to see how far a certain value is from that nothing to determine how unusual it might be. Okay, so think of it this way. If my mean is 0 and I have a z-score that's right there on it at 0, that means there's no difference between them. But if I have a z-score of 1, I know exactly how many standard deviations away from 0 it is. It's 1. Okay, so it's just a standard way of thinking about the normal curve. If I'm standard, if I'm starting from nothing, then I can see how far away I am and how unusual that value is because the z-score tells me that. The farther away from the mean the z-score is, the more unusual it would be. If I had a z-score way up here, way above the mean, that would be more unusual than if it's closer to 0. All right, so that's how that's the best way to explain kind of what that standard model would look like. So z-scores are very helpful. We are going to be using this formula quite a bit. It is not on a formula chart, so you will have to remember it. And then hopefully that helps you understand what z-scores and standardizing is all about. I'm going to talk about the rest of the notes in another video.